Sources available.
Can you see atoms and molecules?
No. I said if it is possible. That's what I said.
That's a hypothetical question. If it is possible, then naturally the properties can be useful, no doubt. But till now we have not come to that level.
Thank you, sir.
So we can have stable nanoparticles only in this range.
Sir, in your earlier slide you have mentioned 1 to 100 nanometers. Yeah. Why not 200? Why not 300?
Yeah, there is again dispute about this range, but generally it is even not 100 nanometers. The nanoparticles are more reactive when this size is smaller. For example, 1 nanometer particles, they will be most reactive. So depending on the requirement, for which purpose you are using, whether you want the smallest nanoparticles or in the 100 range. Although some people say 200 nanometer also is a nanoparticle. It is. But this range is very important because in this the properties are entirely different from the range which is higher than this. So once we have the different properties and then we select the particle size, because as you have seen, once we change the particle size altogether, their optical properties, for example, they show different colors. So that is the energy levels, that quantum effects are very important. If you have more than 100, again they will be very close. The energy levels will become very close, not useful. Yeah, please.
Why quantum effect is observed only at nano level?
At nano level, it is, as you have, I think in BSc, when you go to atomic scale or molecular scale, then these quantum effects are there. In the bulk, it is, the energy levels are continuous. I think you have studied that, As we go and decrease this size, the energy levels start coming apart from each other. So that is called quantum effect, right? So when you are going down, when we reach this, earlier it was only this atomic and molecular scale, there we say the energy levels are discrete. So the nanoparticle size also in this range where you have discrete energy levels, not continuous, because it is different from the bulk, right?
Nanoparticle की stability कितने time मिलेगी होती है?
Stability, it is very stable. It is not, you can keep it for long, no problem.
Cluster नहीं बन सकता इसका?
Cluster बन सकता है, और that's why Dr. Sharma has shown you some experiments where they are using the capping agents. We have to make a layer around this nanoparticle so that it should not bind with the another nanoparticle.
So what is the property of nanoparticles?
Yeah, they may so that's why we have different types of capping agents. So depending on the requirement, we can use. Or what we can do is we can have some processing, like we can heat them at a very high temperature where the lattice lattice effect will be there and lattice properties will change and then it becomes stable.
During the use of nanoparticle, agglomeration is a major problem.
Yeah, that's why we use capping agents. That's why we use capping agents so that they do not agglomerate. So,
better please stand up.
Sir, regarding cancer therapy using nanoshells, let's see the liposomes and anything. So, how these nanoshells are recognizing these cancer cells?
Yeah, I told you,
after metastasis,
around this, whenever there are cancer cells, that is, they are different from healthy cells. There are amino groups. They are attached with the cancer cells.
groups attached to the cancer cells.
Cancer cells.
After metastasis,
in the body, you have amino groups. Okay?
Yeah.
Amino acids are there. So they are attached to the cancer cells. Now the nanoshells, they automatically will bind these amino acids.
is it apart from the normal cells? Means that
Normal cells, they don't have any attachment around them. There is no amino group. Yeah?
So the amino acids will be helping for the attachment of this.
Exactly. There is an interaction between this amino group and the nanoshell.
So then why we are using that IR radiation for curing that? So can we use
We want to make the cancer cell dead.
So can't we use any drugs along with the liposomes of the drug delivery system?
Yeah, nowadays that in that direction also is going on. But you know, this radiation is more effective. It's easy to give the radiation, isn't it? The drug again will be a problem. It may damage the healthy cells. It may not cure. It may interact with the healthy cells in a different way.
So similarly, the cosmetic agents can also make the mutagens. Similarly, the cosmetic agents that we are applying, as said, told, many cosmetic nanomaterials are there.
Yeah.
They can also cause damages in our DNA and make.
Yeah, that's why I told you that there is a possibility. That's why a lot of research is going on. You know, they can damage, but you know, again we have to test these. We have to find out what they will do. You know, a lot of research is needed. There are concerns. You know, there are concerns.
Thank you, sir. So normally the cancer cells are having amino acid groups outside the cell, right?
Yes.
Thank you, sir.
In continuation to previous question, we understood that we cannot use it beyond nano level. But why can't we use at micro level?
No, we can use micro level. It all depends on the properties. What type of properties you have. Again, the energy levels. You know, you need discrete energy levels. In macro level, they will not be there, right? So that's why we try to use in this range. Certainly we can use in micro level.
So what is the difference between a micro and a liposome?
Excuse again, repeat.
So what is the difference between a micro and a liposome?
Micelle and liposome. Micelles are normally formed when you have a surfactant. A synthetic surfactant, you take that and you dissolve in water. If it is soluble in water, it will form micelles. You know that. A liposome, we have to use, for example, phospholipids, which are natural surfactants. You know, natural surfactants are also in our body. So liposomes, it's a name given for the such structures when we are using phospholipids, particularly. Yeah. And these are bilayer structures. Micelles are not bilayer structures, these are bilayer structures.
Sir, you have said that surface to volume ratio increases at nanoscale. Is there any role of different forces in changing properties at nanoscale?
It is mainly the surface area. You know, as you stretch, I have given you that, you know, chingam which you use. So just increase the surface area, surface to volume ratio changes.
Sir, forces का कोई role नहीं होता nanoscale.
In what?
Forces जो होते हैं sir, properties change.
They are all different, you know. So nanoparticles, once they are formed, there is no forces. They are digital particles, just like particles.
Thank you, sir.
Nanocrystals. No, you can grow nanocrystals. Now again, you know, there are many factors. Factors like temperature. If you change the temperature, the properties of the nanoparticle changes. They may become nanocrystals. You know, but depending on the pH, so many factors are there. So all these factors one has to optimize to get whether we are getting nanocrystals or nanoparticles, or you know, I showed you flower-shaped nanoparticles. So they are just change the temperature or pH like that, and you will get different types of shapes. So it's the arrangement of the you know, system, how it is. Yeah, thank you.
Thank you, sir. I would like to request Kapil sir to present the token of appreciation. Now I request all the teachers to join our guests for the lunch in the principal room. The refreshments are being provided for the students outside the seminar room, and we'll begin the session at 1:40 sharp. So you are requested to kindly join us for the same. Thank you.
भैया सर को सर सर रिकॉर्डिंग ब्रेक ये वाला ये बटन दबा